I am Gunika of class +2 non-medical, and today I am going to present a PPT on electrochemistry. Electrochemistry. Electrochemistry is the study of production of electricity from energy released during spontaneous chemical reactions and the use of electrical energy to bring about non-spontaneous chemical transformations. Electrochemical cells. There are two types of cells. Galvanic cell. It is a cell in which electricity is produced by spontaneous reaction. Example, Daniell cell. Electrolytic cell. It is a device used to carry out non-spontaneous chemical reactions using electricity. These are the galvanic cells. These electrodes are active as they take part in the reaction. Galvanic cells. These are the some reactions of the galvanic cell. In a galvanic cell, the half cell in which oxidation takes place is called anode, and the half cell in which reduction takes place is called cathode. Electrode potential. A potential difference develops between the electrode and the electrolyte, which is called electrode potential. According to the IUPAC convention, standard reduction potentials are now called standard electrode potentials. Cell potential. The potential difference between the two electrodes of a galvanic cell is called cell potential, and it is measured in volts. It is also known as cell electromotive force (EMF). These are the reaction of cell potential representing a cell. In the representation of cell, the anode is kept on the left and the cathode is kept on the right. In anode, metal is represented first, followed by a metal ion. In cathode, metal ion is represented first, followed by a metal. Put a vertical line between metal and metal ion. Put double vertical line between the two electrodes. These are the cell reaction and half cell reactions at cathode and at anode. The cell can be represented as follows. How do we calculate standard redox potential? This is called standard hydrogen electrode or SHE. Now that we have a standard, we can calculate standard redox potential by using the table of standard redox potentials. These are the reaction of standard electrode potential. We can calculate the standard electrode potential as follows. E naught of copper is 0.34 volt. This is the table of standard reduction potential. Setting up of a cell. Half cell with a lower standard electrode potential is taken as anode and that with a higher value is taken as cathode. Nernst's equation. Nernst's equation shown for the electrode reaction is given. For a Daniell cell, the Nernst equation is as follows. Electrochemistry. It can be seen that a E cell increases with increase in concentration of copper ions and decrease with the increase in concentration of zinc ions. Measurement of the conductivity of ionic solution. The problems we face in the measurement of resistance of ionic solution are passing of DC changes the composition of the solution and the solution is difficult to connect to a bridge. These problems are solved by passing AC current instead of DC and using specially designed devices called conductivity cells. Variation of conductivity and molar conductivity with the concentration. Conductivity always decreases with the decrease in concentration. This is due to the number of ions per unit volume also decreases on dilution. Molar conductivity at a given concentration is the conductance of volume of solution containing 1 mole of electrolyte. Limiting molar conductivity. The molar conductivity at the zero concentration is known as limiting molar conductivity. This is the graph of molar conductivity versus concentration. Determination of limiting molar conductivity. Electrolytic cells and electrolysis. In electrolytic cell, external source of voltage is used to bring about a chemical reaction. Batteries and fuel cells. Batteries are classified as two types. Primary, use oxidation reduction reaction that cannot be reversed very easily. And secondary, reactions of these batteries can be reversed. This is the diagram of Leclanche cell, also known as dry cell. Primary cells. Dry cell, it is a compact form of Leclanche cell. The EMF of the cell is 1.45 volt. Alkaline battery. Nearly same reaction as in dry cell, but these are under basic conditions. The reaction is as follows. This is the diagram of a mercury battery. Mercury cell. The cell potential is approximately 1.35 volts. Secondary batteries. The batteries that no longer produce a current. These batteries can be recharged easily. Lead storage battery. This battery is recharged by a current from the car's alternator. These are the lead storage batteries. The reaction of lead storage batteries is as follows. On recharging, cell reaction is reversed. This is a nickel-cadmium battery. The cell reaction is reversed on recharging and EMF is approximately 1.4 volt. It is also called as Nicad cell. It's hydrogen as a fuel. Cars can use electricity generated by hydrogen fuel cells. This is the diagram of hydrogen fuel cells. The reaction of fuel cells are as follows. Corrosion. It involves the slow destruction of metal as the result of its reaction with moisture and gases present in atmosphere. The reaction of rusting is as follows. The cathode is further oxidized by atmospheric oxygen to form rust. This shows that how salt speeds up the process by increasing conductivity. Prevention of corrosion. These are some methods for the prevention of corrosion. Thank you and have a nice day.